All right, welcome back. This is an ALEKS topic that's called identifying the limiting reactant in a drawing of a mixture. I think it's a really good topic for us to start thinking about limiting reactants and sort of getting a sense of what we mean and sort of some of the terminology. And it's also good to visually think about or visually see, what we're talking about when we're talking about, these sort of chemical reactions. So I'm going to do two versions of this problem to give us some extra practice, but let's go ahead and get started. So the first two questions, and these questions are really based off of this box here. They're asking us, based off of this box here and this chemical reaction, what's going on. So the first two boxes, it really is as simple as counting how many of each, molecule we end up having. So in this picture here, I'm going to end up with 9 H2 molecules. If you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, we get 9 H2 molecules and only 4 N2 molecules. So these first two questions, that's really just count these up and tell me which one is the most and which one is the least. So most is going to be H2 and least is going to be N2. Now for this last problem, this is really what the important part of this question is, right? Obviously just counting up my number of H2s and my number of N2s, that's pretty trivial. But what's really important is figuring out or understanding which reactant is the limiting reactant. So to do that, we need to combine, our information up here, how many of each do we have, and then also our chemical reaction. So this chemical reaction, I'm going to rewrite this. So our chemical reaction says we're going to take 3 H2s, so this is my H2s, and 1 N2. So let's color these in. This is my N2. So I'm going to take 3 H2 molecules, combine that with 1 N2 molecule, and I'm going to end up with 2 of these NH3 molecules. So this is going to be NH3, that's N2, and then my NH3 will look something like this, and I'm going to end up with 2 of those. So this is what we would call a balanced chemical reaction. I'm going to take these 3 different H2 molecules, combine it with 1 N2 molecule, and I'm going to rearrange the molecules. I'm going to rearrange the atoms to end up with these new species. So this is telling us what the mole to mole ratio is. So it's 3 to 1, gives us 2 moles of NH3. And then based off of our initial, numbers of H2 and N2, the question is asking which one is going to run out first. So if every reaction requires 3 moles of H2, well, we're going to consume the H2 3 times as fast as we're consuming the N2. Each reaction, right, only requires 1 mole of N2. So even though we have more H2, we're actually going to be using it up more quickly. So there's a number of ways to sort of think about this. There's a number of ways to do the calculations. What I would recommend, the way that I sort of teach limiting reactants or stoichiometry, is I'm going to figure out how many quote-unquote reactions I can do. So if I have 9 H2 molecules, I'm going to multiply that by 1 reaction over 3 moles of H2 per reaction. So I'm just using this coefficient here of 3. For every one of these reactions, that requires 3 moles of H2. And then this is going to tell me that I could do 3 sort of equivalents of reactions, or 3 reactions. I'm going to do the same thing for N2, but in this case, each reaction only requires 1 mole or 1 molecule of N2, so I could actually do 4 reactions. What this is going to tell me, I'm going to directly compare these two numbers. This is going to tell me that H2 is actually the limiting reactant. So the number of reactions is 3. After I do 3 reactions, all of the H2 is going to be gone. So down here, which reactant is the limiting reactant? That's actually going to be H2. Another way to think about this, maybe visually, is to sort of go through, this is my starting number of moles of H2 and N2, and start canceling them out. So 1, 2, 3, that's going to be, 1 reaction. That's going to react with 1 of my N2s. So then 1, 2, 3, 1, that would be another reaction. 1, 2, 3, 1, that would be another reaction. And I'm left over with 1 more N2. That's what we call an excess reagent. All of my H2 has run out. I've used it all up, right? I used all of those 9 H2 molecules. I've had enough N2 to react with all of those. So the H2 is gone, limiting reactant. The N2 is still left over. This one didn't participate in a reaction, so this would be my excess reagent. Let's do one more example. So in this example, we've got, looks like O2 and SO2. So here we've got 2 SO2 plus O2 goes to 2 SO3. So this is my O2 and SO2. So let's go ahead and just count first and foremost. O2, SO2, so 1, 2, 3, 4, 5, 6, 7 O2s. Just make sure we did that right. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6 SO2. So the first two questions just based off of that counting. Of which reactant is the most initial moles, that's O2. Obviously this would then be SO2. Now for this part here, it's not just always going to be, whichever one has the least, right? If we go back to our question up here, it actually was, our limiting reactant was the one that had the most. So we have to, figure out this last part. Sometimes it's going to be, the one that has the least, but not always. So here I would sort of do that same exercise or sort of think about, well, which one is going to be, what's the multiple ratio? Which one's going to be using up the O2 or the N2, SO2 more quickly? So 7 times 1 reaction over 1 mole of O2 means I could do 7 reactions with the amount of O2 that I have. And then my SO2, each reaction is actually going to require 2 moles of SO2, so I could only do 3 reactions. So in this case, reactions. My SO2 is going to be my limiting reactant. I'm going to run out of that SO2 more quickly. We could go through and do that cancellation example as well. Every 2 of these only requires 1 of the O2s, so I'm going to use up the SO2 more quickly. So however you sort of look at it is fine, but we need to be able to determine the limiting reactant pretty efficiently. It's something that's going to be used again and again and again.